Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one more problem on Star Delta Transformation. You are given one network and you have to find out an equivalent resistance between the two terminals A and B. Between A and B, they have already given us lots of resistors. We have to combine them and find out one single equivalent resistance between the two nodes. Now, as I've told you before, you have to first quickly identify if there are any resistors that can be combined using series or parallel combinations. So if you look at this given network, this 2 ohm and this 4 ohm, they are in series, and this 4 ohm and this 11 ohm are in series. So that's the first step we can perform. We can simply combine the two resistors, calling them to be in series. So if I draw the equivalent circuit, it will look something like this. 4 plus 2, these two resistors will be collectively called 6 ohms. 6 ohms here, and this is 6 ohm again. This 10 ohm and this 10 ohm will remain untouched as of now. This resistance is 15 ohm. This is also 15 ohm. Now if you look at this two resistors, again 4 ohm and 11 ohm, they will be added and that total resistance will become 15 ohms. This is my terminal B, and here there is terminal A. This is the terminal A. This 2 ohm is being added with 4 ohm and written as 6 ohm here. So this is what we get. Now if you once again try to figure out, there is no more series or parallel combination of two resistors available. So the next approach will be applying Star Delta transformation. You have to carefully identify delta or star and accordingly go for the transformation. Once again, in this circuit, we can define multiple stars and multiple deltas. Most of the times it will be enough to convert one or two stars to deltas or deltas to stars, and that will give us a network that can be simplified further using series parallel combination. So in this case, if you carefully observe, it will be easier to convert a delta. You can see there is a delta formed of three resistors here, 6 ohm, 6 ohm, 6 ohm, and similarly there is a delta here also of three resistors, 15 ohm, 15 ohm and 15 ohm. So if I choose these two delta networks and if I connect them to star networks, then let us see what are we going to get. Before you proceed with the transformation, just make sure that you will simplify the network by doing that particular star delta transformation, which is possible by quickly figuring out what will be the next few steps, and that will help you to understand whether you should go for this particular star delta transformation or not. So for example, if I take this delta and replace it with star, now I had told you this before also, please do not go by the shape. You may not always have delta available in a triangle shape. This time there are three resistors connected on the three sides of a square. They still form a delta network. That is because this is one common point between these two 6 ohm resistors. Because we have drawn it in the form of a line, it takes the shape of a square. But this is one common point because there is nothing else on this entire line. Now this is second common point and this is third common point. So there are three nodes between which three 6 ohm resistors are connected. So if I now replace delta with star, I'll get one resistor here, one resistor here and one resistor here, because star will always have a center common node and the other three ends will be exactly same nodes that we had in the delta resistor. Similarly here also, these are the three nodes between which 15 ohm resistors are connected. This will be one resistor, this will be second resistor and this will be third resistor, and that's how my star will appear. So once I've converted delta to star, you can easily make out that this resistor 10 ohm and this resistor will be in series. This resistor here 10 ohm and again this resistor will be in series. I'll be going for parallel combination after that, and adding them with the two end resistor will give me equivalent resistance between A and B. So my choice of delta to star transformation is just perfect. So let's now calculate the values. We will first consider the delta with 6 ohm resistors and find out what is going to be R1, R2 and R3. Once again, because the delta has the same equal resistors, all the values in star network will also be same. R1 is equal to RA RB upon RA plus RB plus RC. You